Hello everyone. In this video, I'm going to give you overview of the DSAT crop modeling software. As you know, DSAT stands for Decision Support System for Agrotechnology Transfer, and then it will allow you to conduct detailed experiments on your computer to analyze the uh, different simulations for your experiments, management practices, and climate conditions. It was originally developed by the researchers, and some of the major components here I'm going to discuss here, and a brief overview how we will see the different sections of the DSAT in this video. So let's start with the DSAT. Open the DSAT, and now you will see the different crops here, their applications, climate change, seasonal. In the seasonal, you can run your experiment for more than 1 year, 10 years, how your crop growth or yield and different parameters are going to change according to the climatic conditions. In the sequential, you will going to have a sequential experiments which will help you to tell like a multiple cropping system. We have already some built-in experiments here. And the spatial, you can verify the different across the different fields, a yield of the same variety or the different varieties across the different fields. And then we have one more section, yield forecast. So for the DSAT to make any file, let's have a look at the any file here. Let's go to the maize. In the cereals, you will find maize. In the fiber, you will find cotton, forages, alfalfa, bahia, bermuda grass, bracharia. And in the fruit crops, we have a pineapple model here, legumes, chickpea, cowpea, dry bean, faba bean, peanut, soya bean. And then in the various, you will find fallow. Fallow means there is no crop, that is only used in sequential cropping system. For sugar, you will find sugar beet and sugarcane model. Vegetables, we have bell pepper, cabbage, green beans, sweet corn, and tomato model. So in the cereals, you will let's go and have a look at the experiment. So let's go into the click on the maize, and you will find list of the experiments here. Let's open the first experiment, maize irrigated and rainfall. If you click on this, there will you see the brief description here, like which were people involved in this experiment, which was the site of the experiment, and when it was published. So all this is a basic description. So the treatment names, the factor levels, you can see here the basic description about which cultivars were used in this experiment here. So and the field sites, so the soil analysis, this is the brief description. Let's right click on the file, click on edit file. It will open a new window which is known as the X. So let's have a look at this X file here. So let's see here what we have here. This is the maize irrigated and rainfall experiment. This is the experiment name. File type is experimental because it was run for 1 year. This is the year 2002. Here these are the crops, and then this is the people general information. Here you can see this is the address, site, which for site was used here, Brazil, and this was the main opening window for your any experiment, X file, X build. So let's go to the file environment. You will see the field section. In the field section, you will know which sites were used to conduct the experiment. So in here you will see the weather station here. So the weather station name was Piracicaba, Brazil, and that was the file name. So let's see one thing important here. So we have a file, the weather file already available here, BRPI. So that was the research station for characteristics name. We will show you in how to make the weather file, weather station for the DSAT in a weatherman. So the first two digits 02 indicates that it's for year 2002. For example, if it's 2003, then it will written as 03 here, and 01 means it only contain 1 year weather file. And so this was the soil texture name. We will also have a look at the soil modules, like how options for simulating soil, water, nitrogen, carbon, and pH balance, how to make a soil file. This was the depth, the drainage, if there is any information available. And then we have two experiments here, two treatments. One is the rain fed, the other one is irrigated. So you can see that in the irrigated we have a different file but the same weather station, different soil file but the same weather station here. Now let's go to the initial conditions of the soil, what was entered here. So the measurement date started its month March 01 and 2002. It doesn't indicate the date of sowing, remember, it is only the measurement date. So in this case we have a previous crop here, maize already, and this is the crop residue that was available. If you know the crop residue you can enter here, and what was the percentage of nitrogen residue in the soil. If there is an initial, if you have any initial survey for your soil, you can add here like the residue nitrogen percentage in the soil was 1.5%. And what does it mean incorporation? Incorporation means that all the residue were mixed into the soil by using any tillage activity. And to what depth? Like 15 centimeter. You will press OK here, and then there is one more after profile here. In the profile section you can see the depth, what was your conditions of the soil, initial soil. Volumetric water 20 at 20, 40, 120 centimeter depth. They took the soil samples from the three different depths. And then the ammonium, this is the gram nitrogen per megagram of soil. Remember, this is the megagram of soil, not milligram, megagram of soil. So, and if you don't have any other, like you can add the available water percentage and nitrogen kg per hectare, and then it will click on recalculate, it will recalculate automatically. So these were conditions for the rain fed and irrigated. If you want to add more here, we'll see all these factors in how to make the XBuild file. So let's go to the soil analysis, third option. So we have nothing here. So we can also add the soil file separately, but these were the soil analysis. So environmental modifications, in the environmental modifications you can see that date, if there's any modification you did with the, like you want to see the growth at the end result, the yield, by changing the radiation to 5%, 10% of the available day maximum temperature. We will see in the environmental modification how you can use that in your file. So let's go to the management, and there you will see the cultivar. Cultivar means they use the 4 varieties for each rainfed and irrigated. So if you right click here, if you click here, not right click, you just click here, you will see different other options here, that what were the available varieties that were there and their name. So how to look at these varieties? You have to go to your C drive. Let's go to your C drive where the DSSAT directory, click on it, and then you can click genotype. You click on genotype, and there you can see. So for maize, let's see, for maize we have MZX, remember. So we will go for this one, is not MZX starting from, so this one is the maize. So remember, you have to go only to the cultivar file, not eco species file. You have to change anything, or you have to look your cultivars available in the DSSAT, go to the maize x DSSAT cultivar file. You can see the type file here. We'll click on it, will open in the notepad. So these are the different genetic coefficients which are available, on which basis the varieties are defined. So in the first you can see here some P means phenology, G means growth, and N more not used for calibration. We will go into another video where we will look how to calibrate your already available file. So this means P1, P2, P5, G2, G3, Fint, AX all. So these are the brief description, what parameters, what genetic coefficients we are using here, and which factor is which one. So these are all available. So here the minimum and maximum means that the value of P1, which is related to phenology P, we already look here. So its minimum value is 5 and its maximum value is 450. So all the values are in between the 5 and 450. Similarly for P2, P5, which belongs to phenology, G for G, so growth 400 to 1100, you can see. So all these available files are here. So if any case, if you see any hyphen case in front of your any coefficient, that means this will not be read by the DSAT. So this line is not going to be read by DSAT. DSAT will only know this. This is the code McCarty 84. This is the code again. This is P1, P2, faint, G1, G2, and different parameters. So these are the brief description here. So let's go back to our experiment. So you will change your variety type here, add here. If you don't have already, you can use any available one, and then we will go for the calibration process. So then click on management planting. Here we will see what was the planting date. So the measurement date is always change from the planting date. So measurement date is always 1 day or 2 days before the planting date, the day which you did your soil analysis before sowing. So the planting date, the emergence date, if you have anything with the hysteric sign is necessary to add, otherwise you will not able to see your simulations here. The planting method is dry method they used here. Planting distribution either rows, hills, or uniform broadcast. Plant population at seeding it was 7, at emergence it was less. Row spacing was 80, direction from north 45, and planting depth is 5. So then we will go for irrigation. So remember we have two treatments here. One is irrigated, the other one is rain fed. So in case of irrigation treatment, you can see here the day, amount of water, and which operation was used. And then fertilizer. For fertilizer you have two experiments, one is a rain fed, the other one is irrigated. So you can add more levels depending on your treatments. So it again show you your fertilizer, which fertilizer. If you click here you will have a different option, multiple options here. And the second one was urea, how it was, what is the application of fertilizer, how did either bend it beneath surface, broadcast, bend it on surface, to what depth we used. For NPK we use nitrogen, for urea we use 50 kg per hectare, and similarly you can see here. And then if there are any organic amendments, so let's see, check about the organic amendments. So there are no organic amendments were added here. So in this experiment, tillage, so the no tillage were shown in this experiment, but you can add here which tillage implement you used, and it should be must be before the date of sowing. Either you use chisel plow, Dix plow, and to what depth you used. You can add here. Harvest. Then moving on to the harvest, we said we did the maize experiment. You can name anything here. Unreported dates, that is linked with the in the simulation options. So the last was chemical applications. If there is any chemical application, any fungicide, herbicide, pesticide you did, fungicide, you can add here their chemical application here. So let's go to the simulation options here. So the simulation date should be 1 day before the my planting date. It should not be the same planting date. For how many years we are running this experiment? Only one. We have only one replication. Start on a specified date, which we are mentioning here. So options, clicking on options, we will see yes what we want to see in our simulation options. Either you want to see the water, yes, nitrogen, yes, symbiosis, because this is not any peanut or soybean, any legume crop, so no symbiosis, no phosphorus, potassium. But for tillage, yes, and actual level of CO2 we have to select here always Hawaii. Let's move on to the methods. So weather we already measured. We make a weather file, we put it into the DSAT, and then we linked with it. Initial soil conditions has reported, evapotranspiration method, soil conservation. We have different soil conservation method, photosynthesis, radiation efficiency, Ritchie water balance in hydrology, method of soil organic matter series. Series and century. Century are only used in the sequential cropping system, whereas for series we will use in 1 year experiment or 2 year experiment. Soil evaporation method we will use on the back end is Solomon-Ritchie, and soil layer distribution, that is a modified soil profile. Management, let's go to the, so planting, we already mentioned the planting date here, on reported date, either it should be automatic, we can use anything. So you can see here planting in management, we have already mentioned the planting date here. So in simulation option we will tell it that it is according to the specified date. Then let's go to the option, sorry, management, planting, irrigation, on reported dates. As we see in the management, we mentioned the that was on reported dates. Fertilizer on reported dates. Organic amendment, no application. Harvest at maturity, it will automatically harvest. Either way, you can also give it the on reported dates. So in this way, we will go here and we will enter the our harvest date. So what you want to see in your output, always click yes. We want to see yes, summary, overview, growth factors, carbon, water, nitrogen, phosphorus, no, disease, no, chemical, no, verbose, normal output. So we will press OK here, and then we will see the treatments, how we manage our treatments. Then the next section here, the first is rain fed, this variety, this variety is rain fed, this variety is rain fed, and then all the four varieties were irrigated. So how we mentioned the which cultivars we selected here, we have to select here in which field we are growing. Initial condition we have mentioned, either rain fed or irrigated. Planting was done on the same date. Fertilizer and simulation control means which simulation we option have set here, it will respond to that here. So let's press OK. We're going to close this file and we are going to run this file and see. So in the, if you go and click on this file and click on data, you will see the maize average file, mza, mzt. T means the time series data which were collected here. CWAD, these were the codes. I'm going to tell you about the codes which code referred to. This is the average file, like harvested weight at maturity, harvested weight maturity, harvest index, leaf area index, combined weight at maturity, the biomass, anthesis day, maturity day. These were all the minus 99 means these readings were not recorded. So we'll see how we can make these files. We click on experiment, we will click refresh here, we will click this file, and then we will click on run. So which file you want to run, which one do you choose? Run model, it will take a minute, less than a minute. Then we will click on analysis, and then here you will see which file you are mentioning here. So let's go to the overview file. We will have a look at the overview file here. So this will tell you run 1 means this variety which was rain fed, this was a maize variety, this belongs to the weather station, and then experiment is rain fed, name, treatment 1, crop, planting date, this all overview what you have done. So now you can see that this was the soil analysis which we added. Then this is the main simulated crop and soil status at main development stages. So here we will see the biomass. The biomass at the starting simulation date 0, leaf area index, and how it goes to until harvest, this one. So these are the basic main growth and development variables. What was the anthesis date? The DSSAT upon adding gives us 53 and measured was 54, which is a very good. The DSSAT is telling us a very perfect about the simulations. And what was the physical maturity day? They are same. this is the measured as actual measured in the field, and this is simulated as given by all the conditions we give to the DSAT and gives us the different details. So top nitrogen weight, so these are the different development phase, and stress factors, is there any stress available. So now this will tell us the maize yield. Nitrogen uptake, nitrogen applied during the growing season, we applied 70 kg. It dry matter constitutes about 127, and 50 yield productivity is 52. So similarly for all the files we can see. Now go back to the DSAT. Let's go to the summary. So in the summary we can see our different parameters: DWT, CWM, harvested weight. What does this code refers and where you can find their link, I will tell you right now. So just close this. This is the summary related to nitrogen, number of applications, how much nitrogen is uptaken, and what there is a 2 applications of nitrogen, and how much nitrogen is applied, 70 kg per hectare, how much is uptake, what is the nitrogen leaching, mineralization, and N2 emissions from the soil. So now we will go to the plant grow out. We can also see the different soil nitrogen out, soil balance, soil nitrogen balance, soil temperature, weather dot out. We can see the weather file here, NTO dot out, and we can also go for evaluate dot out. Plot. So let's say we want to see anthesis day. Click on next. Either you can. So let's see. Click on the statistics. So anthesis date observed was 58, simulated was 58. Their ratio R square, standard deviation, RMC, and D statistics. So this means that our experiment is really perfect, has the D statistics more than 0.9. RMSE is also good. Press OK. Similarly, you can go for the different things here. Now let's go to the plant grow out. We will click on plot, not view. So the bold items here are showing that these were measured in the field. We have already the measured data with this. We measured the top weight, leaf area index. So the remaining were not bold. It means they were not added in the file. Select all runs. Click on next. So you can see how the top weight, so which indicates the dot means this treatment. These points are showing what were our observed values, and this is lines indicates the DSAT simulation. So you can go to options, days after planting, either date, press OK. You can see, then click on next runs, next. So this is all the experiment. It's showing date of after simulation day, after like at 20 day, 40 days after planting. So we can also export this same data result into Excel. Let's click on here and see what we get here. So it will take a minute depending on your computer. Let's wait here until we get the whole results here. In the like day 0 we have top 0 weight, and day 7 we have 20 kg top weight. Let's go to back. Oh, there's some error because we are already opening this file into the Excel here. So I'm going to close this file. So close this one, retry, goes. I will click on close the program. So in the plant grow out, You can see some other factors also as a leaf area index and some other factors which were simulated. So let's close this. So now you will go into the codes section, codes. So you will see here which code was representing here. ADP means anthesis day, anthesis date. So here you will see all the factors. For example, CWAM means tops weight at maturity. So which codes you can see here. Even you can also see for growth stages which code has used for growth stages. And details mean everything that you have used in the DSAT. So DSAT, and then this one is juvenile calendar. So this means that we will only use the juvenile dates in the DSAT for making the weather files either or A file T file. So it means the first month of January first date means 1, but the first day of month of May means 121. So in this way we will have your leap years and for standard years. Pest.cde, which codes are used if you are using the pest model here for any crop. Simulation CDE refers to your different, like for example, either for in simulation options water, there is only yes or no. Y means yes, N means no. And similarly you will see some other methods here, even for the fertilizer. And then output.cde, what output et dot means. Et phosphorus dot out, soil nitrogen dot out means soil inorganic soil nitrogen output file, soil carbon output file. You can see whatever you're going to select here. So these are the basic codes. Crops, model, the experiment, if you, cereals here in the file. You will see the update LST files. If you make any new weather file, experiment file, list file, you can click here. So this is a general overview of any experiment. Similarly, you can go here and check. If you click here soil data, you are going to make a new soil data file. We will see in the other videos also how to make the experimental data A or T file. A means average files which are only measured once. If you click on refresh here, this will automatically uncheck all the boxes. Weather, seasonal analysis, rotational analysis. In accessories you will see the glue, sensitivity analysis. There is a configuration. Let's go to the tools here. So I want to show you one more thing here. If you go to your C drive directory where your DSAT folder is available, then if you click on maize, if you open this one, you will see your experiment here, which was BRPI 0202. So what does the 2 means here? Let's click once again, open here. So this was experiment number 2. It could be 3, 4. This was the year. So the last 2 digits 02 and 2. So we will see in the same DSAT drive here 0202. 02 first 2 digits refers to your year, and the last 2. If you click here, you will see all the basic details about your file here. Thank you everyone for watching this. I hope this overview gives you a better understanding, but with the passage of time, as you see the other videos, this is a general overview. So let me know in the comments if you have any other questions. Thank you so much for watching this video.